Well, hello there, and welcome to another episode of The Making of Gemini. Sort of. So, a lot has happened in my life since the last time I made a video at all. I had some stuff happen at work, good stuff, not bad, and I bought a new house. I don't know if you can hear the echo in this room, but my office is not yet furnished. So there's a lot of echo. Hopefully it doesn't come through too much. But yeah, so a lot of stuff has happened. I will make a vlog about it if you want. I'm not going to make it if nobody wants it. So let me know in the comments if you want to hear about all the things that have changed. Maybe I'll give you a tour with the new house. I don't know. But in this video, I'm actually going to go back to working on Gemini. So if you haven't seen my other videos about Gemini, basically I was starting to make a game that's inspired by Pokemon or Digimon or Yu-Gi-Oh! Or any of those monster catching type games, mostly Pokemon. And I was making it in Game Maker Studio 2, and then kind of petered out for several reasons, part of it being my life, but also a lot of people told me that it's probably not a good idea to make a Pokemon game. So I was calling it Pokemon Gemini, and it was going to be heavily influenced by Pokemon. And a lot of people said it's not a good idea because Nintendo will go after you, and turns out they do. They don't like Pokemon fan games. And I don't want to deal with the legal aspect of all of that, so it kind of put it on hold. But I'm coming back to it with a whole new approach. So first of all, it's not Pokemon Gemini. It's just Gemini. So it's Gemini spawn of Castor and Gemini spawn of Pollux. Those are the two paired games. I'm still going with the paired games thing because Pokemon doesn't have a monopoly on that. And it's still going to be a monster catching and fighting game, which again, just the genre. But because it's no longer a Pokemon game, it's not going to have any Pokemon property, no Pokeballs, no Poke Centers, no Poke anything. And that gives me a little more freedom to design the mechanics the way I want to, rather than, sticking to the Pokemon formula. So we'll see how this goes. This might not take off. I might not finish this, but I want to give it a shot. So as part of the change over to a new approach to this game, I'm no longer using Game Maker Studio. I'm going to be using modern JavaScript, so ES6, which is the latest version, well, I guess technically ES9, I think, whatever the latest version of JavaScript is, but using the syntax that was added in ES6, which, if you don't know what that means, just basically the new stuff. And by doing it in vanilla JavaScript and HTML5, I can guarantee that people can run the game on any web browser. Now, that doesn't include old web browsers, so if you haven't updated in a couple of years, that could be a problem. If you're still using Internet Explorer, I don't care. It's not going to be supported, but you really shouldn't be using Internet Explorer anyway, so tough luck. But everyone else will be able to run it. So let me show you what I have so far. It won't look like much, but then I'll show you the code behind it, and that's going to be this first episode, just me showing you what I've done so far and catching you up. The next episode, I'll start adding more stuff on camera so you guys can follow along with me. So this is what I have so far. So there should be music playing. Oh, I think you guys can hear it, but I can't because it's getting picked up by my screen recorder. I'll have to adjust those settings later, but yeah. So this is scrolls with me so that I'm always on the screen. And yeah. Okay, so all the graphics and audio that I'm using right now come from OpenGameArt. It's all publicly available. If I can get some people to help me out with the art stuff, then I'll have custom art later. But yeah, so that's basically it. And then I've created a tile set maker for myself, so I can pull in like an image with tiles, and then I can create a tile set to create the levels basically, and then I can save it. I can import maps from other tile sets. Yeah. So this is basically how I'm going to be designing the levels in terms of the backgrounds. And you'll see what that actually generates in a second. So now I'm going to go through the code. So here's the code that I have so far. These are just music. And I'm getting over a bit of a flu, so ignore any coughing. I swear I'm not dying, as far as I know. But yeah, so long story short is I could have used an existing engine, something like Phaser or something, but I decided I wanted to create everything from scratch. So the entire engine is just pure JavaScript created by me from scratch. So this is just the back end, which doesn't actually do anything yet. In the future, it'll be used for anything that needs to be synchronized to a server. So for instance, high scores, maybe multiplayer stuff if I get to that point. But right now it doesn't do anything. Here's the main page. It's just got this canvas where all the stuff is drawn to, and then the two, the CSS for styles and the actual JavaScript. I'm using modules, which are a relatively new addition to JavaScript, which allows one JavaScript file to import other JavaScript files, which allows me to keep all my things separate and still only have one little script here in the actual HTML file, but then this script can include all the others, so I can keep everything clean and separate. And so then in our main JS, we got all of these things. So I have an image renderer, an audio manager, sprite managers, sprites, audios, and tile sets. So these are just constants. So for instance, if I open up constants, which, you know what, let's do it this way. Constants.js. You can see right now, sprites, audio, and tile sets are empty. They get loaded in later, but because these are constant, it allows me to keep track of all of the things that are loaded in. We have sprite definitions, audio definitions, and tile set definitions from our assets. So that, you can see here, this is metadata that allows the game to load in all the assets. So here we have our sprite definitions. So the sprites are basically the images that are displayed that are not tiles, are sprites. So in this case, we have like a main character up, so that's when you're moving up. A main character right when you're moving right, which I haven't rendered yet anywhere in the code, so that's why you didn't see it, but it's there. So basically anything that's in these definitions will get loaded into the game when it starts. So we have the URL to the image, the name of the sprite. Now the name and the main and the key here are always the same for convenience, but you can see that so we have like main character up is part of main character, and main character right is part of main character. So these are both part of the same sort of set of sprites, but they're different individual sprites because this one's pointing up, this one's pointing right. But yeah, then these both come from the same sprite sheet. So if we look here, we can see So not audio, images. So this is image characters NPC, main character. So you can see here all of the different sprites facing up, facing right, facing down, and facing left are in the same image. So the way the definitions here work is we say we take from this image, there are 3 frames, and it starts at 0, 0. They are 24 by 32 pixels wide, and they are spaced with 0 pixels in between. So in that case, it's going to start at 0, 0, and then it's going to load 3 frames that are 24 by 32 with no space in between them, and it automatically will load that in and turn it into an animated sprite based on this. And in this case, it's 0, 0, it starts at 0, 32, and it's 24, 32, and that's 32 pixels down, because this is X and Y. So it's 32 pixels down from this one. So that gives you the second row, which is the right. And then I can add in the other ones for left and down, which I might do at some point. But I might just change the art altogether, in which case all I have to do is change this image, change the number of frames, and where the slices begin, how big they are, and how much spacing is between them. And yeah, it'll automatically load them in. For the audio definitions, we have right now just 2. I don't remember if I clicked after loading the game before, but if I clicked, it would have played a sword sound. That was me testing the ability to play multiple sounds, and it works perfectly. So for audio, it's simpler. It's just the name, the URL of the audio file, and then whether it loops or not. So the main background loops, the sword sound does not. Yeah, so that's pretty simple. And then the tile sets, the tile set definitions being metadata are very simple. It's just got a name and then a URL. And the URL is a JSON file. So let me show you what a tile set looks like. So first of all, we have the image, right? In this case, maintiles.png. Again, this is all from OpenArt, opengameart.com or .org. Yes, .org. And this just has our tile set. It has the images itself. But what we actually load in is this maintiles.json. So the tile sets are these long JSON files. Now you can see how long they are. They're very long, which is why I created that tile set maker, so I don't have to type all of this out manually. But basically the way it works is we have an image URL that points back to that image with all the tile graphics. We have a tile size, in this case 16 by 16 pixels for each tile. I think that's pretty standard. I could make it 32 by 32 or something. But I'm just going to stick with the standard 16 by 16. And then we have the list of tiles. So the way this works, let's see if I can even remember. It's been a while since I've actually taken a look at this. But each of these objects is a tile, right? And it just says, hey, it's taken from position 6432 in the tile map. And we already know that they're 16 by 16 pixels, so we can draw that little tile. The position that it's drawn at depends simply on its position in the JSON file. So the top of the tiles we have an array. This means the first 1, 2, 3, 4 rows have nothing in them. The 5th row has 1, 2, 3, 4. The first 4 tiles are empty, and then the 5th, 6th, and 7th tile is like this. So basically, every entry in this array is a row, and then inside each row, which is another array, every entry is a tile. If there's no tile, it's null. If there is a tile there, then it's the X and Y position of that tile in the image. So that's how the tile sets work. And so with our tile set maker, we can load that image, load whatever image we want, grab a tile, and then place it wherever we want. And it's going to put it in the right place in the array when I save it, which I'm not going to save it now because I don't want this messed up tile set. But yeah, so that's basically how it works. And that allows me to just come in here and draw whatever images I want, whatever levels I want, and have a tile set up. Now, in the future, this is going to have extra layers. I'm going to have layers for collision and for movement. So, for instance, on top of the image, I'll also have definitions for which tiles can be passed through, which tiles are water, which tiles are grass, stuff like that, rather than having it be connected to the image itself. This way we can do things like use the same image in multiple places. So for instance, I might have this grass here like this and just fill up everywhere. But like this area might be considered grass and this one's not, so that when you walk in this area you can encounter a monster where you wouldn't hear even though it's the same image, right? So we can do stuff like that by separating them into layers. So there's going to be this layer, then there's going to be the terrain layer that's going to have what type of terrain it is, whether it's water, tall grass, rocks, whatever. And then there's going to be another layer of collision that'll determine which sides you can walk through from one tile to another. So for instance, if this one is a certain collision type, then I can walk through from the right, but I'll be stopped if I try to walk through from the left, right? So stuff like that. But that's not implemented yet. All that's implemented for this are the graphics themselves. So those are the tile sets. So now you know how sprites and tile sets work, at least in terms of their definitions. So we can close that. So then the game is just the main code. The character is an object that represents the character, which if we look, this extends entity. So an entity is any kind of object that will be doing logic, basically. So if there's anything in the game that will be doing logic, even if the logic is as simple as like, render this sprite here. If there's anything that I'm going to put in a level that's not a tile, basically it'll be an entity, may or may not have a sprite, may or may not have logic. But yeah, so in this case, the only entity I have is a character, which you saw was that little girl sprite. So in this case, when you create an object, you give it an x and y coordinate, which starts out at 0, 0 by default, but you just tell it where that coordinate, where it should start out. And then you can see, for instance, so where did I put the character? Here it is. So I create a new character at half the width of the screen and half the height of the screen. And so that puts it in the center, and then it pushes that character into the game. So any entities that are in this game entities array will automatically be processed by the game. So if it's not in here, you can like create an object and not have it be processed yet, and then push it when it's ready. For instance, I don't know if I'm ever going to need that, but yeah. And then you call game start, and it'll start the game loop that runs 30 times a second and does all the logic for every entity and renders the tiles and stuff like that. So I can show you that in just a second. But yeah, so when the web page first loads, the first thing that happens is that this setup function here gets bound to the click event of the game screen. So when I click that canvas, that's when it actually loads everything. I also have a thing here to prevent a context menu, so when you right click on the canvas, you don't get a context menu. And then I have this function called draw loading screen that just draws some text. So you can see here, all it does is it sets the color to black, and then it fills the entire screen's width and height with the black. Then it sets the color to white and draws the text in the center. And so by having that, I can go, hey, draw loading screen, click here to start, and that's how it'll start out. And then once you click, it starts loading, but at each step while it's loading stuff, it'll say, loading graphics, loading audio, loading tiles, blah, blah, blah. So that's pretty much that. And the reason I have that, by the way, instead of loading things directly when you load the page, is browsers have a feature, at least many do, where they won't let you play audio until the user has triggered it. Basically sort of implicitly giving permission. And that's to stop web pages from just kind of auto-playing sounds and music as soon as you go to them, which was a big problem in the 90s and early 2000s. It was very annoying. A lot of sites used to just play MIDIs as soon as you went to them, and you'd have like 3 tabs open with music playing on all clashing with each other and stuff. So now you can't do that. You can't autoplay anything unless the user has triggered it somehow. And so what this is doing by not loading anything until you click the screen, until you click the canvas, that allows everything after this point to play music and sounds because it was triggered by a user clicking it, which counts as implicit permission. If I didn't do this, if I just had it run set up when the page loaded, it wouldn't be able to play any sounds. It would just fail when you try to play sounds. So, and you can see here I have an audio manager, so all I have to do is audio manager.playSound. It'll automatically play, and you saw in the definition of the audio, it says whether it's looping or not, so it'll handle that automatically. I just literally just tell it to play the sound. Okay. So the way the loading works is pretty much the same for all the different types of assets with some minor differences. So I'm going to show you one of them and then I'll move on. Excuse me. So for instance, the sprites, when the game loads the sprites, what it does is it goes through all those sprite definitions that I showed you. Yeah, it goes through those definitions, and then it takes the name and then the definition object itself. It creates a new sprite with that name, the definition name, and then it calls sprite.load. So the sprite object has a load method that can be called where you pass it a URL and then it loads that sprite and returns and stores it in itself, this new sprite that's been loaded, this image, and all the information about it. And then it just draws the loading screen to show you what percentage of sprites are done. And then, so it takes the frames. So the sprite has a slice method, which, let's open that up for a second because I don't entirely remember what that does. Oh, yeah. So the sprite.slice, sprite.slice will take the sort of x, y width height of each frame and then the number of frames and all of that, and it'll store it all in itself so that when it goes to render, it can use those variables and it'll render just the bit of the image for that sprite. So, so I passed the number of frames and then the array of slices from the definitions. All of those values get passed in, and it creates that slice for us. And then I store it, in the sprites object. So that sprites came from this constants, which originally started out empty. This then puts it into that object keyed by the name of the sprite. Right? So, So this way, this sprite has, so multiple sprites can have the same name, but they have a different key, and this is stored by the key, so you can have multiple sprites with the same name and still access them independently, like we did with the multiple sprites with the, for the main character, but in different directions, stuff like that. And then once it's finished loading, it just freezes the object, and that just makes sure that after it's loaded, that object can't be edited. So these are constant variables, or constants, I guess. Constant variable doesn't make sense. They're constants, and then the objects themselves are frozen. So the whole thing becomes ineditable. Once it's loaded and can't be changed. And that's just to make sure no code accidentally changes stuff while it's running. So like if it's rendering some sprite, but then that sprite gets removed or renamed in the map, it'll break things. So that makes sure that can't happen. Same thing with the tile sets, except tile sets have slightly different things. There's no slice method, but there's a load from JSON. And then sounds is the same thing, but also includes the URL and whether it loops. Yeah. So it's pretty straightforward there. So now we can look at the game. So the game itself, this kind of does all of the overarching logic. So it creates a camera. The camera gets imported from this file here, which, long story short, it just moves the entire viewport so that, for instance, like, so you saw when I was showing the game, when I moved close to the edge of the screen, or close to the edge of the canvas, the whole screen would move to follow me. And the tile set would shift in the background and all of that stuff. And that's all handled by this camera object. So we pass in the context, which is just the thing that lets us draw onto the screen. We pass that to the camera, and then the camera can automatically shift everything, move everything around to match where it's supposed to be. So for instance, every tick, which if we start the FPS is 30, so it's 30 ticks per second. So every tick, we update the camera, and that will literally you can set a camera speed, and then by calling this update, it'll automatically move the camera over time. So you can, instead of just setting the camera's position, you can also just set the camera's speed and have it move independently on the X and Y and stuff like that. So then every tick, we update the camera's position, we clear the screen, and then for every tile set that's been loaded, and this is importing it from the same constant, so it's the same tile sets. For every tile set, we tell each tile set to render itself. And then because the camera is updated, that actually translates everything. So we render it at 0, 0, X, Y, top left. But with the camera's translation, it might actually render in a different position based on the camera movement. So we don't have to worry about that because the camera handles that. And we can just tell it to render at 0, 0. And then for each entity, which right now there's just the character, but for each entity, we then draw the entity on top of the tile set. So pretty straightforward. Everything's kind of abstracted away, so we can just say something like tile set render and entity draw. And then the entities individually will figure out what that means and how to do it. Right? We have an input manager, which I don't think I use. Oh, I do. Okay. So right now so the input manager handles inputs. So it handles clicks and mouse movements, key presses, stuff like that. And right now the main game uses it just to listen to mouse clicks. So we say, hey, inputs.mouse.listen. And so we can listen for a press. And then if it's button 0, which is a left click, button 1 is right click, button 2 is middle click, I think. Something like that. So it's just standard JavaScript, but yeah. So then it listens for a key press and then runs this code for a mouse press, and then runs this code every time we do, which just triggers the audio manager to play the sword sound that we loaded in. So that's why when you click on the screen, it plays the sound. Yeah. So that's that, and then when you start it, it'll stop it just in case it was already running, and then reset the FPS, and then start it again, start up the game loop. Stop just clears the game loop. And yeah, that's pretty much that. Then there's this attach. All the attach does is it attaches the game to the canvas. So it takes the canvas, it takes the context from the canvas, that's the like where you can draw onto. So the canvas is the actual element on the page, that's square, where everything shows up, and then the context is sort of the virtual place to draw stuff to, a surface to draw stuff to. So this takes a canvas and a context, and then it also then attaches the camera to that same context and attaches the inputs to the canvas, so that way you can do stuff like inputs mouse listen, and this will listen on that canvas for presses and not outside. So this just keeps everything contained to that canvas. And the entities, which I showed you before, anything that gets pushed to here will end up drawing itself, or attempting to, every tick. And that's pretty much that. The input manager, the input manager contains a keyboard and a mouse. And when you call attach, a keyboard manager and a mouse manager and a canvas. And then when you call attach, it sets that canvas to whatever you attach it to, and then also sets the mouse, detaches the mouse and attaches it to canvas. I don't seem to have a way to reattach the keyboard to something else. But that makes sense. So when you click on an element on a page, wherever the mouse is determines what element is clicked. But when you type, if you have like a text box or something, then that text box will get the typing, event, like mouse down, or sorry, key down and key up and whatever. But for a canvas, there's really nowhere for it to focus any text input, so it's not going to capture those events. So basically you can't bind a keyboard to a canvas, or at least I don't think it would work correctly if you tried. So instead, the keyboard manager, as you can see here, let me show you the mouse manager. When you call listen to listen for events, it will add event listeners to the canvas, right? So when you attach, it adds the event listeners to the canvas itself. The keyboard adds it directly to the entire document. So the whole web page will capture those key presses. And yeah, again, that's just because a canvas doesn't really capture key events, but it will capture clicks and stuff. So yeah, so basically all the keyboard manager, mouse manager is simpler. So all the mouse manager does is it constantly if you want to get the position, it'll constantly track the position, the mouse X and mouse Y. And it does that by putting a mouse move listener. So every time you move the mouse on the canvas, it will capture the X and Y. And then, so that way, at any given time, I can say like input manager.mouse.pause, and that'll tell me the X and Y position of the mouse at any given time relative to the canvas, so relative to the game screen. And then there's the mouse down and mouse up. So when I click down or release, we have this, excuse me. So the press function and release function. The press function will call any listeners if it wasn't pressed before, but it is now. It'll trigger this fire listeners for presses, and then when you release, it does the same thing, and then the fire listeners just goes through this array of listeners for that given type. So all the presses, all the press functions, or all the release functions, or whatever. And then it goes through and it triggers all of those functions. So yeah, so that way it just handles clicks and stuff unless you give it callbacks. The keyboard manager is similar, but it has this set of keys that are pressed. And so every time you press a key, when you press a key, it adds that key to the set. When you release a key, it deletes it from the set. And so by doing that, not only can you listen for the press and release events to determine when you've pressed and released a key, but you can also at any time call isPressed, and that'll return whether the key is being pressed, which lets you do things like check if a key is being held down. Because when you, it's only going to fire these event listeners when you first press the button down. But if you hold it down, you might want to know about that too. So that way you can check with this if the key is still being held down. And by using a set, it makes it a little faster, and it also makes sure that every key that's being pressed down is only listed once, and it can't get duplicated or anything. So that's pretty much the input manager. The audio manager, we saw some audio manager.play. So we have this load function. This will load the sounds. So this keeps track of the sounds. So if I don't want to load sounds multiple times, because sounds tend to be pretty big, even OGGs, which I'm using, which are relatively small, they're still big files, especially like background music and longer sounds. So in this case, if it's already been loaded, if that sound has already been loaded, it's just going to immediately return that sound. It's not going to try and load it again. If it hasn't, then it will create a new audio, and it will set the source to the URL, which is going to trigger to start loading. And then once it's finished loading, it'll add itself to the set of sounds, and then set whether it loops or not based on the actual definition, and then resolve. So this thing right here is just a way to make these work with promises. So promises are a relatively newish thing from ES6, which is 2015, 2016 was first added, I think. But basically, it allows you to do things that run in the background, sort of. Not exactly, but basically they'll run in the background while the code does other things, and then they'll return something once they're finished. And so a lot of built-in stuff in ES6 and JavaScript lets you kind of return promises naturally. So for instance, if I want to load a page from the internet or load something from another website, I can use fetch, and I'll pass in like the URL here. And that automatically returns a promise, which means I can do stuff like .then, and then it'll have the response, and I can do whatever with the response, and that'll wait. So if I were to do this, right, what it'll do is it'll go and fetch from this URL, it'll grab something from online, but it's not going to stop the rest of the code. It'll continue the rest of the code and then allow it to keep running without blocking everything. And then once it gets that back from the website, then it'll run this and log it. So that's how promises work. And you can also, in async functions, which is literally just put async in front of the function name. In an async function, you can do await, And what that'll do is, it means I don't have to do .then. It'll still do the same thing. The function will stop here and wait for that, and it'll return back the final value. But anything that called the function won't stop. So it allows you to kind of have the function be a little synchronous, meaning it'll block and wait, but the rest of the code still treats it as if it's asynchronous, so it doesn't block it. So it lets you do some interesting things. But not everything natively supports promises. So for instance, audio does not. So when I load this audio by setting the source to the URL of the audio file, it doesn't naturally return a promise or do anything with promises. So what I do is I create my own promise, and then I return that, and then I have that resolve. So this is resolve and reject, which is basically success or error. And once it's finished playing, or once it's finished loading, then I call resolve. And by doing that, this makes this async. So now it'll load asynchronously, and then it'll return its value, which is in this case the actual sound. It's all this audio. Once it's finished loading. So yeah. And then on error I reject, because that's what reject means. Yeah, and then I can get a sound by name, and that'll give me the audio, because that's the actual audio object, because that's what's in this sounds map. And then of course we have play sound that gets the sound by name, and then if it exists, it plays it. I don't know why I have a wait there. Yeah, I'm not entirely sure why I have an await there with an async, because audio sounds, if I remember right, when you call play, it just starts playing. It doesn't return a promise of any kind. That might just be left over from something else. I might be able to remove that later, but for now I'll leave it. But yeah, so that's how the audio manager works. The camera, as I said, you can set the horizontal and vertical speeds and the positions. Excuse me. You attach it to a context. So if it's already attached to a context, it restores the previous values, because it's going to transform it, right? It's going to move everything around in the drawn context, because that's what the camera does. So if you attach it to something else, it's going to restore whatever it's currently attached to, assign itself to that new context, and save the current value. That way it can be restored later. Set just sets the position, and then this is the magic, this set transform, right? So when it updates, all it does is add its horizontal speed and vertical speed to its x and y and call set. So set is the magic. It just sets the transformation matrix. So I don't fully remember the order, but it's basically a 2 by 2 by 3, no, a 3 by 2. Yeah, it's a 3 by 2 matrix, which is just essentially it's a mathematical sort of like a 2D array. So you'll have like A, B, C. It's gonna be hard to type, so let's put this down here. You'll have like A, B, C, D, E, F, right? And each of those letters represents a number. So there'll be numbers stored like that, in this case 3 by 2. And that gets multiplied by all of the coordinates whenever anything is drawn, basically. There's some matrix math that involved, and I don't really remember the details. But basically, I think these first 3 are the scale, And then the next three are the position or something like that, or there's a rotation involved. I don't really remember. Point is, there's scaling and rotation and position are all identified by this transformation matrix. These values just make sure that the scaling and rotation don't change, and then this changes the position. So that's pretty much how that works. So that's pretty straightforward. So then we've got the entities. Okay, so the entity by itself, a pure entity with no extra code, is pretty straightforward. It just has a position, X and Y. It has a sprite assigned to it, potentially. It could be null. So you can see here, by default, it's null, and that's fine. And then it has a sprite speed, which is how fast the animation plays. So each entity can have its own sprite speed changed, so they can be rendering the same sprite, but at different speeds. And so then we've got a basic draw for all entities, which is if it has a sprite, it advances the sprite based on the speed, so that it advances to the next frame or 3 frames ahead or however fast it should advance. It does that. And then it renders the sprite. Pretty straightforward. And then I'll show you the sprite code later. So I think the sprite code is probably some of the more complicated. The character entity, we already saw a little bit of this, but basically all it does is check from the game inputs. So the character imports the game, right? So that main game, everything from that main game can be accessed from inside an entity because it can import that. So we have access to the game, which means we have access to the input manager and the keyboard manager and all of that. So we get the camera, the canvas, and the keyboard manager. We check if the keyboard, if you're pressing shift, then the speed is 4, otherwise it's 2, and that was what allowed me to run a little bit faster. And then the X speed and the Y speed are calculated separately based on, it takes the speed and it multiplies it based on whether arrow right is being pressed, arrow left, arrow up, and arrow down. Now I can factor out the speed and just kind of put this speed here and do that. And it'll do the same thing because that's mathematically equivalent. So I'm actually going to do that. Just because I think it's a little cleaner to only have the speed listed once. But yeah. And then this is every time it's drawn, which we saw happens every game tick. So it calculates the speed, and then it adds the speed to the current X and Y position. And if both the X and Y speed are 0, then it turns off the sprite speed, it sets it to 0, and sets the sprite to index 1. So index 1 is the second frame, which in this case of the walking animation, the second frame looks like it's standing still. So basically, if the speed is 0, so you're not moving, then it sets the sprite speed to 0 and stops the animation and sets it to the frame where you're just standing still. Otherwise, if the speed is not 0, if one of those two speeds is not 0, so you are moving, then it sets the speed to 0.1 times the speed. By multiplying it by the speed here, it means that when you're running, the animation will play faster as well, so it'll sync up with your actual movement speed a little better. And then, since we grabbed the camera from the game, we can manipulate that directly. So this code just checks if you are close to the left or right side of the screen, then the camera's horizontal speed will equal the negative of your speed. So that if you were running, let's say you're running that way, then you get to the end, the camera is going to start moving that way. So that way you stay in the same position, but everything else moves, right? Because if you're moving this way and the camera starts moving that way, and the camera is actually going to just outpace you, and you're going to start to backwards in frame. But if you go this way, and then the camera goes this way, then they cancel out, right? And so you seem to stay in place at the edge, but everything else moves around you. Right? So that's how that works. And then if you're not by the edge, then the camera's speed becomes 0. And notice that I'm not checking if your speed is 0 at this point. It doesn't matter because the camera's speed is always going to match your speed when it's moving. So when you stop moving, the camera's going to keep moving until you're outside of the edge of the frame, and then it's going to stop. And so it's going to kind of synchronize itself just by math. Then this does the same thing but for the top and bottom. And then this calls the entity draw function just to draw the sprite itself. So pretty straightforward, and you can see here you give it the X and Y position, and then it passes that to the main entity code, but it also passes this main character up sprite. So every character will start with the main character up sprite automatically at a sprite speed of 0.2 frames per tick, I guess. In GameMaker they're called steps, in other games they're called ticks. Sometimes they're just called frames, but usually frames are about what's rendered and not about the game logic. So yeah, anyway. Yeah. So that is that. And so then the last thing to look at, well, okay, so we have a renderer which doesn't do anything because this is just sort of what Java would call an abstract class. There's no such thing in JavaScript, but basically it has an attach function, and you can attach it to a canvas in a context, and then it has a render function. And basically specific types of image renderers then extend from this and implement their own render function. That way they can all be guaranteed to have this attach function and a render function. But they do different things depending on what they're rendering. So in this case, we have an image renderer. So an image renderer is just a basic renderer that renders an image. It keeps track of whatever images it has to render. It can load images in, and this works the same way the audio works, except with an image instead of an audio. And then the render function will go through, and if it'll look up the image by name, and then if it finds one, it then will use either the image width or the width that you provide. Same for height. So S width and S height are source height and width, and then width and height are destination. So this is so SX, SY, S width, and S height determine the location on the original image that we're going to draw. So the top left corner, and then the width and height. And then once we extract that, we can draw it on the screen at any position, X, Y, and with any other width and height. So it'll stretch it or shrink it or whatever if you give it a different width and height. But all of these are optional. And if you don't specify them, it's just going to use the width and height of the image itself, right? And then it draws that image. So that's a basic image renderer. The sprite renderer, we already saw that a sprite will then render, it calls the image renderer, but it passes the sprite's image and all the frame height and width and stuff that it gets from those slices. Then we have this image tileset, which renders stuff differently. This image tileset actually just calls an image renderer ultimately, But what it does, loading, yeah, so this will do the actual tile sets. It'll do the loading and all of the handling of the tile sets themselves. So this will grab the JSON file and read it as JSON, interpret it as JSON. And these are those tile sets I showed you before. So, for instance, these things. It'll load it. It'll grab the name if there is one. Otherwise, it'll just use the image name, which can be passed in the constructor of the tile set. So you can give it a name, and then if there's another name inside the JSON, it'll use that instead. If there's not, then it'll use the name you gave it. Same with the tile size, that was the 16 by 16, or you can pass another one. And then it loads the image URL. And then it sets the tile. So, yeah, for set tiles, it literally just sets a variable equal to the value within that JSON file, that whole long 2D array. Set tile at lets it set individual ones if you need to. The main magic here is, hold on. Oh yeah, so the load loads the image. Okay, so the main magic here is the render method. So this will render an entire tile set to the screen, which is basically all the background images and stuff, which we saw. I have that tile set maker to make those JSON files. This takes those JSON files and renders the actual image out. And it does that with loops, lots and lots of loops. So basically, it first makes sure that the image and tiles have been loaded, so that tiles array and the image itself has been loaded. If it has, it goes through every row in that tiles array and then checks if that's an array, because sometimes you saw they could be null if that row has no tiles in it. So we check for that, but if it's also an array, then we go through every tile in that array, or the column, if you will. We grab the tile, which is just an X and Y coordinate, and if that tile exists, so if the tile is not null, then we call image render, and we pass it all the stuff. We pass it the image from the URL, so the image that's been loaded, the position, which is X plus XX, so XX is, it gets the width added to it every loop, so it kind of goes along like do, and then goes back to 0 when it reaches the end of a row, and then goes down by the height, and then do. So yeah, so X plus XX is the X position of the tile set plus the offset of the individual tile based on the tile size and the number of tiles it's looked through. So that's basically how that works. And then it passes the tile X and Y, which is where it's coming from the actual image based on, so that's these X and Ys. And then the width and height, and then it's going to, so remember this is the source width and height, and then the destination width and height, because this is just going to the image renderer. So it just draws it at the same width and height that it takes it from. So if it's a 16 by 16 tile in the source image, it'll be a 16 by 16 on the actual screen. And that's it. So yeah, some fancy stuff to abstract away stuff like rendering an entire tile set and loading an entire tile set. But that's basically it. So yeah, it's been about an hour. Perfect timing for me to sign off. Next episode, I will start adding more things, probably collision tiles. So stay tuned for that. Hopefully next episode won't be quite as long, and hopefully you're caught up now. So long story short, I built my own game engine because I'm building my own game. Gemini is back on track. So until next time, keep coding.